Hi, welcome back to LeetCode. In this video, we will discuss LeetCode problem 2683, neighboring bitwise XOR. So, the problem should be that a zero-indexed array derived with length n is derived by computing the bitwise XOR of adjacent values in a binary array. So, binary array means it can contain only 0 and 1. So, binary array original of length n. Specifically, for each index I in the range 0 to n minus 1, if I is equal to n minus 1 means it is the last index n minus 1, then derived I, the value is original of I, the n minus 1, and XOR of the original 0. Otherwise, derived I is equal to original I XOR of original I plus 1. So suppose there are actually 3 elements, 1, 2, 3. So this is actually suppose original. This is the original. So derived will be what? Derived is first, this is not I is equal to n minus 1. So this will be 1 XOR 2. Next is this index. This is actually not the ending index n minus 1. So this XOR value, derived value will be 2 XOR 3. Next is 3. This is the last index n minus 1. The XOR value will be this index value and the 0th index value. So 3 XOR 1. So this will be the derived array. So given an array derived, so we actually have given this input as input derived array. So your task is to determine whether there exists a valid binary array original that could have formed derived. Okay, so we have actually given this output array, and we will check that is there an original array possible or not. So return true if such an array exists, or false otherwise. So a binary array is containing only 0 or 1. So how actually suppose for this example 1, how can you solve this? So derived actually given as 1 1 0. So original can be what? It can be start with 1 1 or 0, right? Suppose I this is one property, some observation actually here. So this is actually suppose A, B, C. This is actually our array. Now, so derived will be what? Derived array will be first will be A XOR B, next will be B XOR C, and C next will be C XOR A. Right? So this is actually our given array. This A XOR B is given, and B XOR C is given, C XOR A is given, right? Now we assume that A, suppose A is 0. We have assumed that A is 0. Now what will happen? We already know A XOR B is given. Here actually A XOR B is 1. So we already know A XOR B is 1. Now we are assuming that our A is 0. Then what will be the value of B? If I do the XOR again, then what will happen? 1 XOR A. We actually both sides have added XOR again, A XOR A. Now this X, you already know that A XOR A, the value is 0. So this will be ultimately 0. So ultimately this will be actually present as B, and 1 XOR A. So what is the value of A? 1 XOR 0. So this will be actually 1. Right? Now B is 1. We now calculated from A that B is equal to 1. Correct? Now we already know second that B XOR C is given. What is the B XOR C value? B XOR C value is 1. Now we have already from A XOR B we have calculated the value of B. So value of B is 1. And we already know that B XOR C is equal to 1. Again, if we do the same thing, B XOR C again XOR B in both side. Now what will happen? B XOR B, it will actually 0. So C will be 1 XOR B. So here actually 1 XOR 1, ultimately this will be 0. So C value is 0, right? Now next is given that C XOR A is given. So C XOR A, the output is 0. Now what is the C value? C value is 0. 0 means if I do the both side first, do the both side XOR of C, 0 XOR C. So this will be C XOR C, it will be 0. So ultimately left side will be A, and 0 XOR C value is 0. So it will be actually 1. Right? Sorry, this will be 0 XOR 0 is actually 0. Sorry. So now the value is A actually you are getting as 0. But what are you starting? We have started assuming that a is equal to 0. So this is one possible value can be. So that's why this will we have to return true. Right? This is clear. Why it is getting true? Now, if we suppose it's false, we are not getting anything. So then we will check with a is equal to 1, assuming that the value of a, because they mentioned that this is a binary string, so it can be 0 or 1. So that's why I will check both the, with assume both the starting index. It will start can be 0 or 1. So if it is from starting at 0, it is we are getting true, or we are matching that the from this calculation this is matching, all are value matching, that we will return true. Else we will start from assuming that when a is equal to 1. Again we will do the same thing. We already know the a is equal to 1, and we already know the a is equal to b is a XOR b is 1. So if I do the b XOR a, so 1 XOR a, it will be 1 XOR 1, it will be actually 0. Correct? So that's why again we will go to the b XOR c, we know. Similarly c XOR a, we know. Actually if we go to the a, whatever the starting a we assume and the ending a we are getting, if both are actually equal, then actually we can assume that this is one possible valid original array. So we'll return to that time. This is clear. Now go to the code. So this is actually the original array we are just trying to create. So we are assuming this is our starting value of a is 1. Okay, so int a is equal to 1. Now we are just iterating the derived array. So this is the a XOR b, we already know. So we are getting the c. So here c is actually a XOR b, we are getting the output c. So what will be the value of b? B will be c XOR a ultimately. I have already proved here that how actually getting here actually b is equal to, or whatever actually the output actually I have 1 XOR a. So whatever similarly I am doing here, the output is c, and the a XOR value with XOR with a, and we are getting this original value of b. So I will actually push this into the original vector. Okay, now for the next derived value, we are getting what? B XOR c, b XOR c, here actually b XOR c. So now here actually what, whenever just shifting to here, so here actually b is ultimately a. If we compare this with, if I map this with the previous, and this will be the b. So that's why I'm just going to the next time that I'm actually shifting a is equal to shifted as a is equal to b. For the next it will be shifted, that map will be similar way. It is clear. Now we'll check that after iterating all the derived value, I will check that whatever the actually we assume at the starting value of a and at the ending value of a, actually both are actually equal or not. If it is both are equal, then this is one possible answer or valid array, and we return true. If it is not possible, then what we'll do, we'll first clear all the original vector, and now we are assuming that the starting value of a is 0. Here actually I have assumed 1. Now we actually assume 0. Now what we'll do, with respect to 0, we'll calculate all the things similar way. Okay, now we'll check that whatever the last value actually I have, that actually equal or not. Whatever is starting, we are assuming here actually 0, original 0, it will store 0, and whatever the last a actually I got from c XOR a, both are actually equal or not. Both actually a are equal or not. If both are equal, they return true, and else ultimately return false in another match. Right? This approach is clear. Now next, one thing actually we can solve another way actually, by without assuming that a is equal to 0 or 1. What are the properties here actually have to? So we actually have, this is suppose our input original array a b c. Now what actually we have given, the output array we actually given, right? A XOR b and b XOR c and c XOR a. Now what I will do, I will assume that, now you can actually assume that both are actually, if I XOR both of these, suppose this is x, y, z, this x, y, z. So if I XOR x, y and z, all of this together, then what will the actual output should be? Now you can assume that a XOR b XOR c, this is a XOR b XOR c XOR a. Now I have already explained in the previous approach, first approach, that a XOR a is equal to 0. Now we will check that there is duplicate a, b or c or not. Now you can see that here actually one a is present, another a is present. So this will be ultimately 0. One b is present, another b is present. So ultimately this will be 0. Another c is present, another c is present. So it will be ultimately 0. So total XOR should be 0 for the derived array. correct? So I will check that whatever the actually the derived actually I have, if I take the XOR of all the values, then it is 0 or not. If it is 0, then I will, this is one valid derived array, otherwise I will return false. Similarly, let's go to the code. So this is initial XOR value is 0. So I am iterating all the derived value. So I will take the XOR value of the current XOR value. So if at the end, I will check that the XOR value what actually I have, that actually, sorry, that actually I want 0 or not. If it is 0, that time I will return true, else return false. Got it? I have actually used the previous approach. So this is actually more optimal because both are actually same, total language should be same, big of n, but here actually we are iterating only the derived array only once, vector only once. There actually we are deriving twice, one for the assuming that is starting with 1 and another is starting for 0. Okay, so time to schedule will be big of n, whatever the derived length actually I have, and space concept will 0 here. But in the previous approach, we have actually used a vector to store the actual original numbers. So that time space concept will be big of n. So if any doubt, any suggestion, you can comment on that. And if you like the expressions, please like the video. And if you not yet subscribed, please subscribe the channel. Thank you.